homework that I asked you to do. Again, the authentic kid is going through and doing these homework assignments. Maybe you didn't understand this problem, so you are going to go on the website Carnegie. I'm going to explain it again. The 9 days for homework, you do some extra work, and you find problems or examples like this, and you do them on your own. I have the answers to the skills practice, so if you ever do anything like that, you can come see me, and I will give you the answers. I'll talk you through them. If you want to come after and ask for some help, that's what the authentic kid does. Okay? So that's the type of learner I'm trying to create in this class. So again, if you don't get this, or you didn't get it for homework, there are other examples on the Carnegie website that you can go to the door and take a picture of that, and that will tell you how to get to those skills practice pages. So parenthesis here, and put a plus sign in between them so it doesn't look like what? Multiplication. What do these guys have in common? And what am I left with? X plus 7. And I'm going to cheat because I know my second bubble should look exactly like this. Well, I look at this guy and it's got a negative here and a negative here. That's good for me since both the signs are messed up, because when I factor out a negative, it's going to change both of them. If one of them is messed up, then I'm in trouble. Because do I have a way of just changing one of the signs? No. Do I have a way of changing both of them? Or if there was 3 things in this bubble, all 3 of them? Yes. Do you get what I'm saying there? You got to factor out. So I factor out a negative. And what else do they have in common? And then negative 4 times what gets me to a negative 4x? I'm just missing an x, because a negative times a positive gets me that negative that I was looking for. And then negative 4 times what gets me to a negative 28? Positive 7. And that works out well for me because I got both those the same thing in both bubbles. What do these guys, what does this have in common with this? X plus 7. What's left over when I pull this out? X squared. What's left in this one? Minus 4. Is this still factorable? Yes. X plus 7. Does this have a square root? Does this have a square root? Is this a subtraction sign? So what do we know this is? Difference of x minus 4, x plus 4. Oh, 2. Thank you. Sorry. My fault. Make sense? Yes.
With the x plus 7 being squared, I love that.
No. Remember when you pulled this out? So this is something that you guys have to see. When you pulled this x squared out, because they both had it in common, how many x squared did you write out here? How many x squared did you write out here? Just one x squared, right? When these guys have an x plus 7 in common, how many do I pull out? Just the one. It's just like this problem up here where I'm pulling out the greatest common factor, because this x plus 7 belongs to both the x squared and it belongs to the negative 4. That's why, because I'm going to distribute it, so I'm going to end up with 2 of them. Yes? All right. I asked you to do number 6 also. Okay. Right away. Again, I should. The big question here that they say is over the complex. So because this is over the complex, I might be dealing with some imaginary numbers. That's what that tells me. Doesn't mean I have to, but it means if I end up with something that could have imaginary roots, I have to factor it all the way to that. So I get, all right, so right here, I should go double bubble. Again, push that negative inside and put a plus sign right here. What do these guys have in common? Now this one's a little tricky. What do these guys have in common? They have an x cubed in common. And what am I left with? X minus 4. Yes? What do these guys have in common? Well, do you see this x is a what? And this x is a... So they're different signs, right? What is this sign? Negative. What is this sign? So they're both switched. That's good for me because I can change that by factoring out a negative. So I'm factoring out a negative. What do these guys have in common? And what am I left with? X minus 4. Why? Because this changed the signs when I factored out that negative right there. Now, what do they both have in common? X minus 4. What am I left with? X cubed minus x. Are we talking about this? So then right here, what do these guys have in common? Because I can once I factor, I can still factor even more. What do they have in common? So I can go x minus 4, and it's going to look weird for a second. I'm going to let it look weird because we're going to talk about something. Do you see the x, where that came from? What am I left with here then? X squared minus 1. You with me? Now, do you see that this is multiplication, multiplication, multiplication? I can move that in any order that I want to. So because this looks weird with this little x in the middle, only because it looks weird. That's it. I'm just going to move it forward in my next step. That's just something that I would do personally. So I would write this as x minus 4. Now, I look at that last thing. Look at this last bubble. Is that still factorable? It's a difference of squares problem. We should be able to see these. We've seen them enough. This has a square root. This has a square root. It's a subtraction. So it becomes x minus 1, x plus 1. Now, does all of those factors, does that make sense since I know from last chapter some stuff? Absolutely. How many roots does this thing have over here? 1, 2, 3, 4. What are the roots? X equals 0, x equals 4, x equals 1, x equals negative 1. Those are all my roots, correct? I could put those roots on a graph. I could then look at my end behavior, and it says it should be up, up, because I've got a positive and an even. And I would go through, and I would plot those, and then draw my little squiggly lines, and it would be a quick sketch. So, last chapter, I gave you this and asked you to graph it. This chapter, I can give you this, have you factor it, have you find the roots, and then plot the graph and use the end behavior, and all this stuff should be coming together, which is so vital while you stay current with me and while you go over. Even when you make a mistake in chapter 3, you need to go back and look at it because it's going to affect your chapter 4. Are you following me? Does that make sense? Now, can I change this problem for just 1 second? Is that okay? I am doing a new problem for just 1 second. Only part I'm going to change is right here. Do you see how they said the set of complex numbers? What if down here I would have ended up with a plus 1 right here? My factors would have turned into x, remember I pulled that forward, x minus 4, and then here it would have been, when I go to factor this guy, it would have been x plus I, because one I is just I, and x minus I. Because it says to factor it over the complex. Now, let's pretend that this problem says, do you see this is I'm still dealing with this one right here. What if they changed this and they said set of real? Then guess what? I would be done right here. I would not factor this to my i's because my i's are not a part of the real number system. So I would have been finished with this problem. Do you see the two differences in the types of questions that they can ask you? and where you're supposed to stop and why, and where you're supposed to keep going and why. It all has to do with what number system they ask me to be factoring over. All right, so let's try b. I told you to factor b just like it was x squared. The reason we can do this is because this is to the fourth and this is to the second power. So I can pretend like it's just x and x squared and just x there. Do you see how this right here is half of this? Do you see how this is half of that? So I can kind of treat it like it's that. So here's what I do. I go like this. Double bubble right away because my a is what? Now I should check something real quick. What could this be a candidate of? Going back all the way to week 1. It could be a perfect square. Why? Does this have a square root? What is it? X squared. Does this have a square root? Yes. 3. What is this times this? 3x times 2 is what? 6x squared. Is this 6x squared sitting here? No, it's not. So is this a perfect square problem? No. But should I check that? Yes. Especially since the check should be pretty quick. Are you following me with that? Now, I need, this says same signs. Oh, that has to be a plus sign too for perfect square, right? And it was. Plus sign means same signs add together, and they're both negative. So right away I can put 2 negatives down there. I need 2 numbers that multiply to 9, but since they're adding, they need to add to 10. What 2 numbers multiply to 9 and add to 10? And so I get x what? Squared minus 9. X squared minus, what can I do with this guy though? It's a what? Difference of squares. So I put x minus 3, x plus 3. This is a difference of squares. X minus 1, x plus 1. And there it is factored completely out. Making sense? Good? This chart is an excellent chart to go through. Down here. It's down here a little bit farther. But remember I went over these in the video? Did you guys, I did these in class with you. Yeah. Okay? The other kids, I did it with them. They had to probably watch the video to get through that. But we should make sure we understand this because this was talking about perfect squares. That was the last part of yesterday's. If you weren't here or if you need to go back over it, the last part of the video, which is up on YouTube, I went over perfect squares. Why this was and why it's not and all that. We reviewed it. So let's look at this guy. This is awesome. This chart right here, you should be able to factor all these. In fact, I would do this for homework. I'm probably not going to check it again. What I'm probably going to do in chapter 4 is I'm going to have you come up when you're taking your test on Monday or Tuesday. I'll probably have you come up and you show me chapter 4 and show me that it's all completed, and I'll just give us a chapter 4 check and make sure that you've done all the pages that we should. I'll just flip through, and it's kind of like a participation for chapter 4.
More points?
No, it can't be worth more points. Participation, aka homework, can only be worth 20% of your grade. So I'll look at how many points we have for tests, how many points we have for homework, and I'll make sure that it adds up to be 20. For my regulars, it'll be 75, 25. Make sense? All right, so here, this guy right here, if I was factoring this, what do I know this is? Difference of squares, because this has a square root, this has a square root, and there's a subtraction sign. So right away, I can throw my bubbles down. The square root of this guy is 3x. The square root of this guy is 4. So I'm going to see 2 3x's, 2 4's, and one's going to be plus, and one's going to be minus. And that's how fast it should take me to factor those. I should start recognizing difference of squares. These factoring cannot take me all day. Very, very, very soon, we are going to have to factor almost 4 problems just to do one. 4 different times you're going to have to factor, and that will be part of one question. So you're going to have to get this factoring down a lot faster. This guy right here, I can just straight up, what do I need to check? Why? This has a, this has a, and this is a. So I need my final check, and my final check is the square root of this is x, the square root of this is 6. This times this is 6x, times 2 is 12x. It is a perfect square. So I can just write down the square root, which is x, the square root, which is 6. I can square it. Now the last and probably trickiest part is what's the sign in the middle? It goes right here because this says same signs. This tells me they're both negative, so it is a subtraction sign that goes there. How are we doing on this?
So for the method of factoring blocks, like that's what we put. We don't put like perfect square.
The method, no, would be perfect square. I'm just doing it.
The factored form would be the x minus 6 squared.
Yes, this probably should go over here. This should go over here. The reasons why, both the front and back number have square roots, and it's a subtraction, so it's a difference of squares. And then you just explain why you're able to know that this is a perfect square. Why you're able to know this is a difference of squares. Because it's not like I'm up here going, hey, you know what, I'm going to call this a difference of squares. There are reasons behind it. This is another good example for what we did yesterday in class. What is this a candidate for? Nope. What was the last thing we did? Difference of cubes. This is x to the third minus, how can I rewrite 64? 4 to the third. What is my a in this one? X. What is my b in this one? 4. And if you remember my form, it looked like this. A, since this is a minus, a minus b went my first bubble. What's my a? X minus 4. Do you remember this from yesterday?
Oh.
It was the last thing that we did, and I told you you're going to have to memorize it, or one of the last things that we did. And I said right here was x squared, or a squared, which is x squared. The middle term is a times b, which was 4x. And since this is a subtraction, this actually becomes a positive here, because they're scaring me. And the last one is b squared, and it's a plus 16. This was from right here. Right there. From this page. And I started, so you need to memorize that. Yeah. Now let's change this problem just a minute, real quick. What if I had changed this problem to x cubed plus 64? If I change that to that, it would become x cubed plus 4 cubed, right? What's still my a here? What's still my b here? But watch how this changes. Now it becomes x plus 4, and in my bubble over here, it's the same exact thing except x squared minus 4x plus 16. No. Total different problem, Evan. Notice, what did this problem have? A minus. What did this problem have? The plus. But they're both cubed. So one form looks like this when it's plus sign. One form looks like this when it's a minus sign. And if you notice, the only difference is this became a plus, this became a, this was a, and this is a. And the way I remember it is, do you see how there's a subtraction here? That's going to be my first sign. See how this is a plus sign here? That's going to be my first bubble. And then I know the middle one, this one right here is the opposite of that. That's how I remember it. Alright, when I go to factor this guy, before I can do anything, what do I need to do? Greatest common factor. I should do that for all these. How many terms are here? So what way do you think I'm going to factor this? By grouping. by doing those little finger around bubble signs. Huh? All right, here we go. 4, 5. Fun stuff. Here we go. We're not going to go through the why. We are just going to get straight to the math. This thing right here makes this seem a lot more confusing than it needs to be. But here's basically what it says. P is the factor of all the constant term, or my A0. Really, it's just saying P is all the factors of this last number. Q is all the factors of the leading coefficient, meaning the front number. And they are factors. I will explain what this does in just a minute. We'll put it all together, but just hang with me for a minute. So if I look at this problem down here, P is all the factors of what number? Negative 10 is my last number. That's what I said, P. So this is all the factors of negative 10. All the factors include plus and minus signs. So what numbers go into 10? Plus or minus 1. Plus or minus 2. Plus or minus 5. Plus or minus 10. You with me? Now Q. All the numbers are factors of 4. So everybody see where I got my P and my Q's from. My factors of 4 are going to be plus or minus 1, plus or minus 2, plus or minus 4. Now what this says is you are supposed to take all the P's and divide them by all the Q's. So what I do is I pick one Q and I start dividing all of these by it. Are you with me? So my list of, and we'll talk about what this list is in just 1 second. I'm going to write my list right here underneath this little squiggly. Here's my list. 1 divided by 1, and I'll do this in blue. 1 divided by 1 is what? So plus or minus 1 is the first number in my list. Comma. What do I need to do next?
1.
2 divided by 1. I start with all these and I take all my P's and divide it by this number first. So plus or minus 2. What's going to be my next one? Plus or minus 5. My last one for this one is going to be plus or minus 10. I am done with this. Am I finished with my list? Because now I have to take all these P's and divide it by this number now. Plus or minus a half. When I go to do this one, 2 divided by 2 is what?
1.
Do I already have that on my list? I don't need to rewrite that. So I kind of skip over that one. 5 divided by 2 is plus or minus 5 halves. 10 divided by 2 is what? Don't I already have that on my list? Do I need to write that one again? I'm done with this one. I'm on my final one. 1 divided by 4 is plus or minus 1/4. 2 divided by 4 is what? 1/2. Isn't that already on my list? Do I need to rewrite that one? 5 divided by 4 is plus or minus 5/4. And 10 divided by 4. What does 10 divided by 4 really reduce down to? 5 halves. Is 5 halves already on there? I am done. this is my possible, now let me explain what this list is. These are all my possible roots for this equation. What are roots? X-intercepts. What am I able to find with my roots? Okay, if I gave you an equation in this form, you could find the roots. What form did you want it to be in? Factored form. So what if I give you all the roots? What can you put the equation back into? Factored form. Do you see how I found all the possible roots? Well, we're going to get there, but just think, if these are all the roots, if I figure out this is a root, if I figure out that 2 is a root, don't I know that x minus 2 is a factor? So let's go. Here's what we're going to do with them. We're going to do this problem right now. We're going to do this problem right here. Let's go through it a little quicker. My p is, what are all the factors of 6? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. What are my q's? Plus or minus 1. So what is my list of possibles? All I have to do is take all of these and divide it by 1. Is that going to change and make any nasty fractions? So I'm just going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, how can I know if something is a root? How can I determine if something is a root? Okay, what is the fastest way of division that we've learned? If I take one of these roots and I do synthetic and it gets me a remainder of 0, what do I know? It's a root because it goes into it evenly, which means I know the factor of it. And then I've broken this thing down. Now, these are the list of all the possibles. That means sometimes you're going to get something that has a remainder, which means it's not a what? Factor. It means it's not a root, which means you can't find the factor. So you got to move on from that one. It didn't work. So here's what I mean. You go through and you try one. For just kicks, I'm going to do -1 as my first one to show you what I mean. I'm going to go through this long division fast. 1, 1, -7, -1, 6. This is my long division. I bring this down. 1. 1 times the -1 is -1. Add these together, 0. 0 times 1 is 0. Bring down to -7. -7 times -1 is a 7. Add those together, and I get a 6. -6, or positive 6 times -1 is -6. And I just guessed. I actually tried to get it wrong. I tried to pick one that wasn't 1. But I haven't done this problem. I haven't done -1, so it didn't work out for me. But, well, what happened with this? What do I know since my remainder is? This is a root, which means what is the factor? X plus 1 is the factor. Are you with me? Now, look what it tells me. Rewrite the polynomial as a product of its quotient and the linear factor. Here's what it's asking. X plus 1 times, what does this tell me? What was my highest coefficient up here? 4. So when I start down here, what am I going to start with? X to the third. How many x to the seconds are there? So I'm going to keep moving on. X to the third minus 7 what? X. Because my x to the squareds, there's none of those. Plus 6. Now that I know this right here, now that I know this, is this still possibly factorable? Is this part still possibly factorable? Yes. Do you see all these guys right here? These guys right here. They are still possible factors of this guy. So guess what I'm going to do? I'm going to try another root and see if it goes into here by using what? Synthetic. Do you know how to factor this yet? Can you factor it one of the ways that I've taught you before yet?
Yeah. Well, it's cute.
It's x cubed. I can't factor it that way yet. Once I break it down to maybe something x squared, or if I had some kind of four-term thing that I could use grouping, or if I recognize this was a perfect square, then I could be, do it a faster way, but I can't yet. So I have to check again. So I'm going to try 1. Remember, what did I say? Sometimes you're going to try this and it's going to work. What? Not work. So let me try a different one. I'm going to try to fail. Let's try 2. I'm going to check and see if 2 is a root of this. Now, do you see how I've broken this problem down? Do I need to go or want to go all the way back up to this guy? No. What do I want to now use as my new function that I'm trying to break down? I'm trying to break this sucker down. Are you with me? So what is my coefficients? 1, what? Good. 0. Because remember, 3, there's no 2's. 1, and then 0. Notice, do you see it's 1, 0, -7, 6? So I can use the answer from here to do my next synthetic problem? Yes? Because there's no x squareds. You have to walk it all the way down. 1. 1 times 2 is 2. Add these together, 2. 2 times 2 is 4. Add those together, gosh, -3. -3 times this is a -6, and it looks like I can't do this wrong. Because what did I get again? A 0. So now what do I know? Don't forget this guy. Don't forget this guy, because remember, it's all this stuff multiplied together. All this guy did is break this part down. Are you with me? So if I want to rewrite everything, it's x plus 1, because that was from right here. What is the factor of this going to be? X. If this is my root, what's my factor? -2. And what am I left with? If this was x to the third, was what I start with, what is this going to be? X squared plus 2x minus 3. Now, does this guy right here look like something that I can factor my normal way? Yeah, now I feel comfortable with it, so I go, okay, x plus 1, x minus 2, that's an x, I don't know what the heck happened here. And then I go, okay, let me double bubble. Since this is a is 1, doesn't have a perfect square, so it's none of those cases. I need two numbers that multiply to 3, but subtract to a positive 2. So it's going to be x minus 1, x plus 3. And there, that guy is totally factored out. Do you see how I broke it down using synthetic division? Do you see how I needed to understand that if something goes into it, it has no remainder? Now, again, if I would have tried, let's go back up here for just a second. Let's try, since we know our roots. See, we know our roots are -1, +2, +1, and -3. You with me? If I tried any of these other numbers, like if I tried a 6, what would happen when I did my synthetic division? I would have got a remainder, not 0, and then I would have crossed 6 off, and I would have had to do another synthetic division problem. And yes, technically that would be a waste of time because it didn't help me solve that problem at all. But there's no other way to do this except for guess. Right now, how many numbers could be roots of this before you make this list? There's an infinite amount of numbers, right? But when I make this list, have I cut it down? Yeah, I've cut it down to 8. There's never a positive or negative of them. So isn't it much easier to check the list of 8 rather than an infinite amount of numbers that I don't know about? So do you see how finding these possible roots is huge? and helping me eliminate, and so I can really dictate and I can factor these guys down.
So you're going until you find a remainder of 0?
Yeah, so like if I keep trying stuff and it doesn't work out, then I keep going.
Okay.
Until I get something that makes a 0, then I can rewrite it as this guy, and then I take this one and I again try to break it down again.
So that's why we could break it down so you can factor it.
Until you can factor it completely by yourself without doing synthetic, and then you do this. So go ahead and for homework, try this number. This is going to be huge. This is, I mean, if you look at this problem, to be honest, I could give one of these problems on the test. And it covers synthetic division, it covers understanding the concepts of roots and all that kind of stuff. You with me?